Hello, everyone, and welcome back. I'm here with Alberto Salazar, who's an entrepreneur and serial conference speaker. He's here today from Ecuador, I think you said, so it's early in the morning for him. He's here today to teach us all about reactive programming and Java. So, Alberto, are you ready to take the stage?
Yes, thank you.
Great.
So let's start. Today I'm here to talk about the story. I'm Alberto Salazar, I live in Latin America. I mostly been working in the around all South America, from Mexico to Chile. I did giving consulting almost every country, and also have customers in the United States. And I also been granted as a Java champion or a groundbreaker ambassador and OutZero ambassador too. And today I'm going to tell you a story that happened here, far, far away from you, projects. And it's based in some developers that want to try to change the way that we think, the way that we do the things. So another way to think about programming in Java, that we are accustomed to work always, and we need to change our minds to create a new reactive services, reactive microservices, and another way to do the stuff that we are get accustomed to do. So, for the beginning, I'm going to start explaining you what we are accustomed to do every day, what we are accustomed to, how we package our applications at this time, and as a Java developers, we know that most of us are working on enterprise and big companies, or like me in the banking industry. We have these huge applications that are packaging as ER files or as Word files or as jar files that complete a big, huge application that we name it monolith. And most of the people also try these huge applications, try to send them to the cloud, and we are accustomed to work with an application server like a JBoss or WebLogic or Western application server or in this modern era, we move to microprofile specifications of Jakarta E specification with new application servers. But we always are working in the same code that is running like the last 22 years, almost like I started Java in the 2000s. And we are talking about this amount of code, these millions and millions of lines of code that is packaged in this way, and have a lot of logic that, like we know in an enterprise application, we have other systems, a lot of databases, and a lot of projects start to move the front end in this era to Angular, to React, or so they start to take out the front end of the back end and they leave the code in Java and start to move to working in Angular or in another framework. Or a lot of people in the last 10, 12 years start to move to Uber jars or Fab jars, mostly based in Spring Boot, and they leave the front end and the applications, the mobile applications in Android and iOS outside of the logic that we used to handle in the backend or in the application server. But we continue working in the same amount of code that is calling a blocking application that is handle certain numbers of threads when you hit the application, when you make a request to the application. Each of these components, it would be the application server or the Uber jars, is going to handle some of the amount of threads that is not going to scale in one time. So you need to scale in more nodes that is going to handle the request. So what we are doing in this application is that we are working in blocking applications. They have some threads in the server that when I make a request, so I want to bring a customer or I want to save a customer, I'm going to send the data. And what is going to happen in the server in the Uber that is running in a container or in a virtual machine is going to save a thread to start all the logic of the application. And then what is happening is going to make me have a logic that is going to be to a database. So it is going to save another thread, but the first one is going to keep to stay in block until the another thread is going to stop to working, and the logic of what we are working inside is going to have the same pattern. So I'm going to save the first thread, and I'm going to work with another threads that are going to be blocking this thread all the time. So what is happening with this, or what is the trouble of this stuff, is that the mostly applications or the mostly VMs that we handle in the hardware is going to run maybe 200 concurrency requests or a little more, but it's going to have a, a limit. So why we don't move or think in another way? Mostly of us are accustomed to work in the same way every day. We are accustomed, the humans are accustomed to do the same and the same. So maybe we don't take a look around and we don't see that we can change the way that we program with a little changes, and we are going to improve in the performance of our applications. So let's think about out of the box. We need to get out of our comfort zone and start to thinking another way. So let's try to explain what is happening with this thing about reactive. The JavaScript developers or the Node developers are accustomed to don't love this concept because they grow since the last 10 years in this publish, subscribe data that these modern applications start to work. But as a Java developers, we don't move forward to that. But what is happening in the market is that maybe we need to think about move forward and change the way that we create the applications, because we start to have, we are in an era that everything changed. We have billions of requests, billions of devices outside. When I create a banking applications, it's not going to work like in the past with just in the web or inside the branches of the bank. Now we are creating fintech that is running around the globalization of the money, and we think we need to think about millions or billions of requests every day. So we need to take a step forward. I mean, we are working in Java. We have the tools to do it. So what is the difference? When I'm talking about reactive programming, that is different to have a reactive application that I'm also going to point out later. We're talking about a node blocking application. So it's going to happen that this thread that we are accustomed that we handle in the in the blocking way is going to work in no blocking way, and it's going to also have the concept that is going to run all the data asynchronously. So I need to send an event to the front or the consumer that I finished the work. And what is the most important thing that I'm going to show you here live is that I'm going to handle a small number of threads, even if I start to run a lot of concurrency. So with this, I am saving resources in my on-premise deployments or in the cloud environment deployment. And what is this change is that I'm going to subscribe my data. So if I am running in a React application or an Angular application, or I'm creating Kotlin or Swift applications, I am able to subscribe to an API. So I'm going to say, hey, backend, give me some customers. I'm going to subscribe to the data. And what is the magic that is going to happen in the backend? We have now the whole stack of technology to create a reactive application that is going to handle also the same concept to the database. So if any change in the database is going to happen that I am subscribed, is going to push me the data to my logic in Java. And then I am going to send to any customer that I have, even if it's another application, in a reactive, and I am in a reactive way. So I am propagating the change. I am using the events to move the data forward without blocking any amount of threads. So I am sending the data in an asynchronous way. How this is happening? So this is happening in a loop. The application in the backend is going to save some of the threads of the hardware or the server. And then when I receive a request, he is going to take a little bit time just to save the say the key, the correlation ID of the data that I'm going to handle. And then it's going to handle the logic or the call to the database or the processing. And when it's finishing, it's going to say, hey, client, I'm going to send you some data with this correlation ID, so receive it. And another concept that we have now in Reactive and in the backend and in Java is that I also can send him for parts. I can say him, so have from 10,000 from 10,000 data for you can handle it in the front or less. It depends on the logic of the application of how we are going to handle the application. So what I make the point is that one thing is that I move forward to programming in reactive way, but sorry, that I am creating a whole reactive system. No? A reactive system have a different, that is the whole application or the whole system that I'm handling from back, and everything that I'm working on the system is going to have four pillars of the reactive system that must react to the user, that is the responsive paradigm, that is going to be resilient, so it's going to always stay alive or always stay able. I'm going to handle mesh trading, that is almost the same that I'm doing with the webflux, and it's going to be elastic. So when I move to the reactive system, it's not just about the programming, it's going to also to have a lot of stuff in the infrastructure or the cloud. And this point, I'm going to just handle the recommendations of reactive programming. So today we are going to see how in Java I'm going to play or to the implementation technique of programming reactive in Java, and on a developer point of view, not the whole systems. So let's start about to see how we move this application from the way that we used to do and the way that we want to handle. And the first thing is that several of developers in this era start to use Spring Boot. And most of Java work in these years is moving forward in Spring Framework and Spring Boot. And so you use the start Spring AO always when I want to start a project. So if you go to start.spring.io and I want to create an API without too much dependencies, without too much stuff, I'm going to use Spring MVC. Because we almost all the applications that we run now in Java are working in Spring MVC. So I put in the dependencies Spring Web, and in the database I'm going to use Spring Data. In this example that I'm going to handle coding today, it could be any database, but I am doing in-memory H2 database. And just for do less code, I am using Lombok at this time until the records in the new Java era is going to be more mature. But the same application, if I look at to the reactive stack of dependencies, is going to be that I'm going to create an application using reactive web, that is Spring Webflux, and that is based in a project named Reactor, and is based in not in a servlet container like the Jetty or Tomcat. It is based in Netty. And now, in the last maybe 2-3 years, there are a lot of work in the community on have Spring Data to DBC. Is a reactive way to get data, or reactive connection to the database that we are also almost always accustomed to use JDBC. And the database is going to be the same for this purpose. So let's show you some code and what I'm explaining you about how we are going to handle this move forward dependencies, of how we change this paradigm of how that we are accustomed to program every day. In the left side, I have the traditional application that if I go to Spring Initializer and I create it and download, it's going to to have these dependencies. It's going to have the Spring data dependency. It's going to have the starter of the web application. Like I said, we're going to handle with H2 database. And the dependencies of the project are going to look like this. But if I do or move forward to reactive without being afraid, it's going to be the web flux and not the web. It's going to be the data RTDBC, not the JPA. And I'm going to need an implementation of the driver that is going to be reactive. So not just the runtime of the H2 database or any database that we're going to handle. I'm going to have to use the R2 DBC driver that is going to be a reactive driver of the application. And how we are going to move this code? They have a little bit difference when I'm costing. When I go into the database, I always we as Java developers are always handling or using JPA. So what I accustomed to have is an entity or a class or an object relationship, mapping relationship that is going to handle the ORM via Spring the JPA. So what I'm accustomed is I'm going to have the entity annotation that is going to be from the specification of persistence of the JavaX persistence. And I have here a simple table that is going to have an ID, a name, and ESCO. But if I move forward in the database connectivity layer to the reactive web, we are going to see a little bit difference on the first. I'm not using the JavaX. I am not using the specification of persistence. So I am using the the new way to go to this R2DBC connection, and the table is going to be from the Spring Framework. It's a mapping table. So we are going to see this difference. This is long, but I'm not going to make the explanation of this notation, but this is giving me the getters, setters, the constructors of the application without making code. And with this differentiation, like you see in the persisting layer, I am not doing too much change. So I am just making a small change that is going to handle the persistent just with a different annotation on the table. What happened with the Spring data, with the interaction with the table? If you create a Spring application or you're a customer of a Spring application, we have these interfaces that give us the framework to interact with our objects that is mapping to the table. And if I have an enterprise application that is based on the specification, most of us are using stateless session beans. But in this era, I think that most of the developers and the architects in Java, we are trying to move forward to this stuff of coding. And what is the differentiation here? Spring JPA and Spring Data is almost 15 years old, and it is really mature. So here I have a lot of Java query is that I can handle the query of the data just with the naming of the method. So if you see here, I'm saying that I want to query the customer table with find by name, and with the API of JPA and Spring Data, I can handle this just in objects with any of the rows or the definition of the table. But if I move forward to create the reactive application. This is going to be the hardest part when you move forward on this stuff. First, I can handle the query just in objects, but it's not hard if you are going to handle or win performance in create like in the old times the query of the annotation. And the difference that the query, like you see here, is from the R2DBC and not this from the Spring data. And another thing that you are going to find when you move forward that is uncomfortable to the mostly of Java developers is that we are now to start with the using Spring Web Flux, we need to learn how to send this information that is going to be subscribed. They have the concept of when is one data is going to be mono, and we have another object that is going to grab our data that is going to be flux. So we see here in the operator what is going to happen is that is a different way to think. Is a lane of data that is going to be changed without mute. And we need to understand how to handle this. This is going to be the hard part that is going to be working with mono and flux. To the API that is going to be when I expose the data. I can handle almost the same code that I used to have in the blocking application or the traditional application or the way that we used to handle with the Spring MVC. That is, I can handle this with the almost same code. But what we are going to change is that we need to move forward the data, the wrapper of our data. Like I said, with Flux is going to be a lot of, so it's a list of customer. If you want to say it here, just give me a list of customer. And mono is going to be if I want to send one object or one amount of data. I can handle this also in a functional route too, but like we have a lot of code writing in this way, it's easy for us to move the same code and just start to work with Flux and run the application. So we move this application and see this difference of what we are talking about, the performance that we are winning in the application. We are going to see here my console, and I have been running the one application that you're going to see here that is based in servlet container. So it's going to be a Tomcat, and it's running in the 8090. So it's the application that we call blocking. And here we have another application that is reactive that you're going to see here that is running on Netty in the port 8080. And I'm going to show you what is happening with this reactive revolution that I'm talking on my point of view of gaining this performance and on moving forward with a little bit changes. So let's run here on the console. I'm going to run 10,000 requests into concurrent threads to one of these APIs that is going to go onto the database to get to save the data to save a customer on the traditional application. And I'm going to do the same here in the 88 port. And let's see what happens if I am profiling these applications. You can see here what is going to happen, and the mostly change is on the thread count of the application. So here I have the reactive application that mostly they handle maximum 23 threads. And it's handling the request without any trouble, without any problem of timing. And what is going to happen with the traditional day that we program and we handle our applications is going to grow until the maximum threads that can handle the hardware. So it's going to try to use as much as threads that I'm going to need. And this is going to have a limit. This is the whole thing about moving from the reactive application, and what is why we are winning on these changes. We are going to deal with this new paradigm that I am published to scrape data, yes, but if I am talking about application that is going to handle a lot of requests, and I am accustomed to be a backend developer that work in Java, not in Node, and I'm going also to use or working in a startup or a fintech that is going to need a lot of resources to handle this request. Or like in banking, we have a lot of code that is old or is legacy. I'm going to handle this reactive application in a better way in our hardware, moving just the logic that is going to be almost the same, because the logic of the Java is not touching. What we are changing here is the way that I get the data from the database and how I send the data to the customers or clients that are taking or making me this request of information. With this point of view, I'm going to explain you or giving a reason that how we, or what is the stage stack that we are handling here. Like I said, we move to all the reactive stack of technology. A little bit second and my is stuck. Just let me know if I continue talking when you are listening. Host. Yes. So what we're watching is that on this stack of technology, what is this? The magic that is happening behind is this project reactor. Spring Web Flux is based in this project, and what I can do is that making these roads, these controllers, what is happening is that I can handle 10 millions of messages per second, and I can scale out this new era of applications that we need to handle. And what is happening is that I'm working with not blocking HTTP runtimes. It not must be netty. Also with servlet 3.1 or 3.0 of the specification, the reactive way of doing application and this concept is also handled by Tomcat, Jetty, and Undertone. What happened in the data? I'm using the R2DBC. So after you get the slides, you can get to these links and try to understand more about it. And for what use cases or why we are going to move forward with all this stuff to move and and work with reactive. I'm talking about that not all the application must do this work, but if I going to build an application that's going to need a lot of requests, I need a lot of latency of consumer requests or high load of multiple consumers, this is going to be a good way to do it. So the real use cases that we are using all of this stuff in the projects that we are handling is in real time data streaming. Let me show you like indicators in real time. We are using all of these reactive stuff in one product that we handle in several banks. That is, we create an API gateway based in reactive. So it's going to be the router of all the APIs that is handled behind the gateway. And when I'm going to handle a lot of data. So in the last part of the session, what I'm going to do is to how we can secure this application. So let's move forward to this application. I want to secure these APIs. For this, you can use any authorization server, but in this time, I'm going to show you a little bit what is Auth0. Auth0 is an software as a services for authorization and authentication or for secure your APIs and applications. It's a really easy to use. So you can open an account with Auth0 and start to use it. It's really easy. So if you want to create an application and that be secure, you can create the application and then follow the the tutorials that we have here in Auth0. You can handle a single page application. You're going to have examples for Angular, to React, to Vue, or regular applications like that run in the backend, like Java, Angular. In this time, we're going to create an API, and we are going to secure the API. So I can going to just say the base demo. What's going to be the identifier when I'm going to make the authentication, so that in the backend we have this API running HTTP localhost slash 8080 slash, and we are running here this application on the API customers. So let's try this. With just this simple creation of the authorization server, you can handle this application to authenticate all the APIs that you have. So what I'm going to have in Java for this is that the same application that we already handle in the reactive wave, what I'm going to have is another dependency. So I am adding the dependency to the OAuth2, the standard of three-party authentication. And I'm going to handle the resource server, also the dependency. The dependency is really easy. And I need to have a security configuration. There's going to be a configuration annotation of the webflow security to say that you need to run or to execute the API. You are going to need the token. And what is going to be the issuer of the token is going to be Auth0. So this time I'm just going to show you for the time that it's really easy to secure the application. So you just put here the authorization server, put the dependencies. I leave you all the code that we handled today in the presentation. And I'm going to make a close of the session and receive some of the questions that you have about what I am going to explain you today. All these goals of move forward to reactive for me is we create some applications that now are working in delivery, the credit cards in Latin America, for example, handle millions of people switching the application to delivery the credit cards, the statements that we continue handle here, not virtually. We handled it in each city, delivery the cards and the statements of the banking. And we are handled here, you can say around 5 million requests per day at least, and we are growing on it. And this is running in small containers that can handle just one CPU and 2 gigabytes of RAM. That is cost a little bit in the cloud. I am talking about environment that costs $100 a month. It's really a small money. It's really an amount of money that I am spending in cloud for this vintage application. And all the authorization we are handling with OCR. So what is the learnings for today, and what we reviewing the whole stuff that we review today? First thing is that it's different to have a reactive system than just be create an application that is reactive and using reactive programming. Using Webflux, if I am working in a Spring Boot application and I want to change to reactive and start to see this performance, or I need to grow in or use less resources in the performance in the application, it's easy to move to Webflux. I have the stack to move the database connectivity to the R2 DBC, so I have a reactive driver to the database. And what I am winning and what is the goal of this learning is that I am saving resources in the, it can be in the infrastructure on premise of the customers of the institutions that you are working on, or in the cloud resources that you start to move. And what it gives us this for the Java perspective of developers or the backend developers of Java is that we can have this kind amount of request in Java without moving to another language. So I'm going to leave you all the code that I show you today, the applications that can run in. You can see it in the GitHub repository of GitHub public repository. I have some articles talking about the same concept and the same work. And I'm ready for you if you have any questions, and you can handle the last minutes in the questions that you have.
Thank you very much, Alberto.
Thank you.
I haven't seen any questions yet. I asked the audience to send them, so hopefully we get some questions. In the meantime, I'm a bit interested. Why isn't everybody writing reactive Java code? What's holding us back?
We are accustomed to work in the same way. Like I explained before in the beginning of the presentation, we're accustomed to always be working in the hard way. And most of the Java developers or the enterprise applications is based in code that started 20 years ago, 15 years ago, and it's really hard to rewrite the code. I have customers in banking that have hundreds of developers in the institutions or in the bank, and they continue creating logic back in the same way. And what we dedicate in the last the 2 decades is try the code move forward without too much change. This is what we start giving these tools, this guidance, and the customers to try to don't touch the logic, but try to make a little bit improvements without too much change. And when we are talking about now in this era of microservices and cloud, it starts to be a little bit easy because like we isolate applications, and it starts to be a little more easier. It's an easier way that we start to move. We continue having old code, and the new code is the person of the developer or the direction of the technical area start to think that they have another tools that or another way to create the application without doing the same every day.
Great. Hopefully we get some, no new questions and nothing from the chat. Well, if you guys don't have any questions to ask Alberto, then I would very much like to thank you for your time. Yeah, so let's
Thank you
end
all.
the session. Thank you very much.
Thank you all. Have a good evening and start of the
Yeah,
finish of the conference.
Yeah, join us in about 20 minutes when it's time for the ending keynote. Bye.